Hello, everybody. Happy Good Friday. Yay, happy Good Friday. Yeah. And I know I emailed this to you all before, but we're in for a treat today as Eno talks about the geology of Ghana. I think it's very interesting, and I know you will find it as well. So thank you, Eno, for doing this today.
Thank you for suggesting I do this. The reason I'm doing this, she suggested it. It was all her idea. I'm giving her the credit. Okay, so hi everyone. My name is Eno, and I'm technically a binational because I have two citizenships, one for the United States and the second one for Ghana, which is where I was actually raised. So right here, this is the Ghanaian flag, or at least a picture of it. The red symbolizes the blood of the people who died in our fight for independence. So this was before 1967 when we actually gained it. The yellow actually represents the mineral wealth of our country. Yes, that's something I'm going to be addressing in this presentation. The green represents the agricultural wealth of the country because we still have a great amount of forest throughout the entire country. I would assume maybe 40 to 30% of the entirety of the country of Ghana is covered with just forest and agriculture. And the black, that's actually probably the most important part of it. That represents not just the freedom of Ghana from European rule, but all of Africa from European rule, because Ghana was one of the oldest African countries to gain its independence. So we're up there on that list. So without further ado, let's begin. So here are the main points of my presentation today. I'll start with a brief geology of the continent of Africa. Then I'll go into the geology of Ghana and why were we once called the Gold Coast. And I'll also have some comparisons between Ghana and Virginia. That way we can at least relate something. And then my last will be references. So if anyone has any questions, I can easily direct you to any of my references if you want to do more research. So first, a brief geology of the African continent. The entire continent is characterized mostly by two major geological features. One half is marked by highly deformed metamorphic rocks and granitic intrusions, and are mostly Precambrian. In other words, they're older than 500 million years. Out of this group, the metamorphic and granitic rocks are divided into two major groups, cratons and former mobile belts. Cratons are older than about 1,500,000,000 years old. They've suffered no major orogenic deformations or metamorphisms since then. So they're still cratons as is. The younger mobile belts are made up of rocks which have been stable since 1,100,000,000 years ago. So those rocks in particular have been termed the Kibaran. Then there are rocks that are 550 million years old, Pan-African, 300 million years old, the Hicernian, and 100 million years old, Alpinian. Mobile belts referred to as here are actually orogenic events or mountain building events. So that's what that means. The other half of the continent is composed of nearly flat sedimentary rocks, often on steeply inclined metamorphic basement rocks, which occupy very broad, shallow basins. And the sedimentary strata of these flat sedimentary rocks is from the Paleozoic era to the Tertiary period. So all of them are less than 600 million years. So on this map, that red circle, that's the approximate location of Ghana. So we are lying on the Precambrian basement rocks. Then there's the Rift Valley to the east. And then we have the late Precambrian to early Phanerozoic. So you'll see them in the Congo Basin, the Turdoni Basin, basins mentioned earlier. Phanerozoic fold belts, again, are mountain building events. So right here. Mesozoic to Tertiary and recent basins. So these are probably some of our youngest basins. And finally, the Mesozoic and younger volcanic rocks. So that's what the very dark patches are. Most rocks in the African mobile belts, again, the orogenic events, they're of the Pan-African age, so 550 million years. In particular, the West African subregion, so this area right here on these maps, they comprise of Archean cratons, Proterozoic terrain, Pan-African and Hicernian mobile belts, orogenies, and Paleozoic intracontinental and Mesozoic Atlantic coastal basins. During the period from 2,100,000,000 years ago to around 1,950,000,000, the early Proterozoic rocks of West Africa were deformed, regionally metamorphosed, and tectonically stabilized. This was referred to as the Hibernian tectonic event. To make a long story short, there was a lot of tectonic movement, and that created some of the hills and mountain ranges that exist now throughout West Africa. The Hibernian event was widespread over the entire African continent and is recognized by the presence of linear zones of metasediments and metavolcanics, which are intruded by syntectonic and late tectonic suites of granitoids. So that's what these maps over here are for. This is the West African craton right here. So that's dated to early Proterozoic with some Archean cratons. Then there's the mid-Proterozoic, which is further down to the southern part of West Africa. And finally, the late Proterozoic to early Paleozoic right here. And this map details the Pan-African mobile belts, again, are orogenies. So they occurred all over the entire continent. And this is another map. So there's our West African craton. Again, Ghana lies in this particular section of it. Mobile zone, so those are some of our mountain ranges within the Sahara, the East Saharan Metacraton, the Congo Craton, and several smaller ones. This map details the ages of the cratons and any overlying rocks. As you can see, we have at least 3 completely untouched cratons. So they haven't been covered by any kind of younger sedimentary rocks, but they are surrounded by them. Again, Ghana lies about here. So we are lying straight on top of a craton that's over 1 billion years old. Now, for some comparisons between Ghana and Virginia. Size-wise, Ghana is approximately 92,098 square miles, and our current population, as of 2021, is 32.83 million people. Virginia is approximately 42,775 miles squared, and most recent population data, 8.624 million. Long story short, we're about twice the size of Virginia, and we have 4 times its population, to make a very long story short. And now for Ghana itself. Ghana is a nation that's divided into 10 regions, a lot smaller than the United States divided into its 50 states. We have 10 regions, you all have 50 states. Each region is further divided into its own districts, each with their own unique names. I couldn't label them all here because there are well over 100, and that would have been an unnecessary number of words. These are similar to the counties in every state, and each region, like the states, has its own regional capital. The capital city, Accra, so that's right here, it doubles as the regional capital of the Greater Accra region and the national capital of the country. So everywhere you see a small white square, that's the regional capital of that specific region. On to the geology. The Birimian terrain, as mentioned earlier, is exposed in Ghana, Burkina Faso, and the Ivory Coast, and is characterized by very large sedimentary basins and volcanic belts. They trend around northeast to southwest. The Birimian formations were formed around 2 billion years ago during the early Proterozoic, and the Birimian outcrops from southwest to north parts of Ghana, they cover around 40% of the entire nation. The Birimian is subdivided into the Lower Birimian and Upper Birimian, which represent mainly metasediments in our Lower Birimian and metavolcanics in our Upper Birimian. So on this map, the layers are arranged from youngest to oldest. So first we have the Birim Diamond Field, getting into that later. The Birimian mafic igneous rocks, so those are these very dark patches. The Birimian turbidic sedimentary rocks, so some of them overlay the Birimian mafic rocks. Tarquean fluvial sedimentary rocks, we have 2 belts of those. Granite rocks, which overlay majority of the mafic rocks. And finally, the Phanerozoic Volta Basin. So this is the basin of one of the main water system of the country, and it eclipses most of the other layers. The rock units of the metasediments of the Lower Birimian are primarily phyllites and greywackies, in other words, dirty sandstone. The upper Birimian, these are our metavolcanics, contain mostly metamorphosed basaltic and andesitic lava. Now they exist as hornblende actinolite schist, carbonate chloride schists, and amphibolites. So you'll find those mostly in these dark green splotches on the map. The lower Birimian and upper Birimian rock types are generally referred to as the Birimian supergroup collectively. The Birimian rocks are isinochronally folded with dips generally greater than 60 degrees. Their general trend is northeast, and faulting tends to follow a trend of folds. So if you find any faults within the Birimian supergroup, they tend to follow the trend of whatever fold might be nearby. Metamorphism of the Birimian is the low-grade green schist facies. The Birimian supergroup were intruded by granitoids during their formation. These were typically hornblende bearing and are commonly referred to as the Dix Cove granitoids, and granitoids after their formation. So these were post-granitoids, biotite bearing, and are locally referred to as Cape Coast granitoids. Yes, after the previous regional capital. So on this map, we have the layers this time going from oldest all the way down to youngest. So our Birimian volcanic belts, the Birimian sedimentary basins, the belt type granitoid rocks. So these were the first granitoids, they were the ones that intruded. Then the basin type granitoid rocks, these were the second type. Tarquinian sandstone and conglomerates within our belts, the Voltaian basin, mostly sandstone, and finally the Pan-African thrust units along our eastern border. Ghana has the following distinct geological terrains, 6 of them. Virginia has 5. The early Proterozoic Birimian terrain, this hosts the known gold deposits that occupy the west and northern parts of the country. So most of this area. The Tarquinian sediments, which are present in nearly all the volcanic belts, some which hold significant gold belts and active gold mines. That was our light blue here. A Pan-African fold belt located east and separated from the Birimian terrain by a prominent topographic relief known as the Aquapim Togo Range. So that is this area over here. Flat-lying Voltaian sediments, which have been preserved. Coastal basins, so along the southeastern portion of the country. And tertiary to recent sediments, with the most recent being alluvial and lake sediments unconsolidated. Concerning the sediments, most of them lie in the basin of what is known as the Volta River. In central and northern Ghana, the flat-lying strata known as the Voltaian Basin overlie the Birimian rocks with a marked unconformity. The lower part of the Voltaian Basin succession includes siltstone, sandstone, tillites, arkose, and shale. The upper part of the Voltaian Basin is composed of a monotonous succession of sandstone. So sandstone after sandstone after sandstone, depending on age and depositional environment. The Volta River, that's all of this over here, is the main river system in the West African country of Ghana. It flows from the Bobo Dioulasso highlands of Burkina Faso. So it starts from somewhere around here or so, and flows all the way through Ghana and then furthermore into the Gulf of Guinea. The main parts of the river are the Black Volta, the White Volta, and the Red Volta. The Black Volta forms part of the international border between Ivory Coast, Ghana, and Burkina Faso. So right here, all of that is the Black Volta. The Red Volta is the first branch that branches off into the northeastern part of the country. And the White Volta is a tributary that flows all the way down from Burkina Faso before it joins with the Red Volta. Further south is Lake Volta. It's actually a reservoir that is impounded by the Nkosugo Dam on the lower Volta River of southern Ghana. It is known to be one of the largest reservoirs in the world. It extends from the Nkosugo Dam in southeastern Ghana to the town of Yaipe in the central Gonja region. So it extends from here to roughly about here. All of that is simply the lake's reservoir. The dam's power plant generates electricity for the Volta River Authority, and the reservoir also provides water transport routes and is a source for irrigation and fish farming. To put it bluntly, this is the #1 source of water for the entire country, and the hydroelectricity produced by the dam is actually great enough that we're able to supply electricity to some of our nearby countries as well. So it's probably our greatest pride. Towards the end of the Avernian event, the rocks of the Birimian supergroup, our syngranitoids and postgranitoids, were uplifted, eroded, and deposited in spaces among the Birimian linear trending belts. These are known as the Tarquean. So these two belts right here. Coarse cross-bedded sandstone, conglomerates, and phyllites are the principal lithologies of the Tarquean. It has been divided into four formations as follows: youngest at the top, oldest at the bottom. Arhuni sandstone, Tarqua phyllites, the Banquet group, and the Kawer conglomerate. Please make note of the diamonds in parentheses. The Kawer conglomerates consist predominantly of closely packed pebbles of very, very fine grained silicified Birimian metavolcanics with quartz, Birimian phyllites, and schists. So if you see any fine grained sand, that's not sand. That's a lot of metavolcanics that have just been eroded, uplifted over the years and ground down into very fine particles. For the Banquet conglomerates, over 90% of the pebbles are actually made up of quartz, and the rest are Birimian phyllites and schists. The auriferous conglomerate bed of the Tarquean is known as the Banquet. That's where it gets its name. The Kawer conglomerate and the Banquet group of the Tarquean actually do contain diamonds. That's why they're so important. And this image right here on the bottom, that's an actual diamond that was mined from this Tarquean belt. We have a gold mine there, and this came up as they mined. I'm assuming by accident or by knots, they found that it was a diamond. Onto our coastal basins. The Pan-African Mobile Belt, again, or orogeny, occupies the eastern and southeastern portion of Ghana, and the rock types were categorized into three: the Dahomean system, the Togo series, and the Buem Foundation. The Dahomean system consists mainly of gneisses and migmatites. The Togo series are predominantly phyllites, schists, and quartzites. We have a lot of these, apparently. The Buem Formation at the northern and northwestern parts of the Togo series, so that would be, I suppose, this area over here, are shales, sandstones with some basaltic lava and tuffs. And along the coast of Ghana are the following sedimentary basins, with their various rocks being mainly shale, sandstone, mudstone, and clay. The Keta Basin, the Acrine series, the Amishian Formation, the Apollonian Formation, otherwise known as the Tano Basin, and the Secondi series. So these mostly contain from sandstones around here all the way up to alluvial and lake sediments, with a few of them containing quartzite, sandstone, and phyllite. Why were we called the Gold Coast? So in the days of colonialism, before Ghana gained her independence, yes, she's the motherland, she's a she was called the Gold Coast due to the large mineral deposits of gold found throughout the entire country. As mentioned earlier, the gold deposits were actually a result of the Birimian Formation and all the tectonic movements that created and uplifted it. The economic mineral deposits are gold and manganese, and gold has played an important role in the economy of the country throughout its history, with up to 1,500 tons produced throughout its modern history. So from colonialism to about now. From the late 15th century up until the mid-19th century, 2/3 of the total gold production from the African continent was estimated to have originated simply from the Gold Coast. This tiny country provided 2/3 of gold that had been transported around the world from Africa back in the 19th century. The crowns, the jewelry, all of that, most of that gold came from us. And it was estimated that the annual production in the early 1980s was between 12,000 to 500 kilograms of gold every single year. So based on our structure and mythology, Ghana is divided into about 8 different gold belts, each represented by geographic regions, underlain by rocks with significant gold mineralization. So they had to be above a certain percentage to make that cut. I'm not quite sure what the percentage is now, but back then I'm going to assume it was around maybe 40 or 50%. The major primary gold lodes are found in the shear zone between the lower Birimian phyllites and the upper Birimian greenstones, and they consist of quartz veins and lenticular reefs containing gold. That's what auriferous meant in the previous slide. It literally means gold containing. The gold is usually accompanied with arsenopyrites. Gold also occurred as massive auriferous quartz veins, mainly within the metasediments, or as auriferous sulfides in the wall rocks, particularly tufaceous bodies. As with this image, a good example would be this yellow dot. Everywhere on this map, you see a yellow dot, that's a gold deposit. And a majority of them, as you can see, were found within the Tarquinian or within the upper and lower Beryllian, with very few being found in the Voltaic basin. Though the massive auriferous veins were the most important source of gold, that's where a good amount of the gold came from, there are also potential for some of the latter sources. The quartz vein type is younger than the disseminated type, which is the massive auriferous. Generally, the quartz veins vary in width from 2 meters to 5 meters, but they can occasionally be up to 25 meters thick, and the length could be 500 meters, and some are approximately 2 kilometers deep. That's a lot of gold. In the Tarquinian, gold is hosted in quartz pebble conglomerates. Alluvial gold is derived from the weathering of primary veins and lode-type deposits in the Beryllian rocks, which were subjected to several cycles of erosion and deposition. So some were found in alluvial fans. Then more alluvial gold is found in levels of rivers, streams, river flats, old river flats, and terraces. So yes, you could have gone down to one of the tributaries of the Volta River, sifting through the sediment for a little bit. If you're lucky, you might have actually found a gold nugget back in the day. I don't know if there's any more like that now. Most of them are in established mines, but in the 1970s, 60s or so, you could actually go down to the river and sift and find gold. This is a picture of one of our larger mines, the Asanka mine. So over here, you can actually see how deep they dug into the earth to find the gold, not to mention the actual bedding and lines of the sediment and some of the mafic rocks. This is of smaller scale mining because we do have some smaller mines, none on the large scale. And this image is an image of actual gold mined from the country. So this is the gold you would find in our country. Now, the McCarthy Fault. Ghana and the Greater Accra region are located far away from any present-day tectonic plate boundaries and active seismic volcanic regions of the world. Thank goodness, because I live there. However, for centuries now, a number of significant earthquakes have struck southern Ghana, with some destructive events, with the most dangerous being 1636, 1862, 1906, and 1939. So these were 4 of the most devastating earthquakes that struck the southern part of Ghana. Recently, in the last 2.5 decades, so 25 years, several earth tremors of magnitudes between 3.8 to 4.8 have occurred around the McCarthy area and the Greater Accra region. Of course, this has sparked concern and speculation about the possibility of a major earthquake in the Greater Accra region. Very bad news. Imagine a severe earthquake occurring in Washington, D.C. That's what would happen if it occurred in the Greater Accra region, because it would hit our capital, it would hit our airports, all the important stuff. We really don't want that. And on March 10th, 2023, at 9:49 in the morning, an earth tremor of magnitude 2.8 occurred in Ghana, and more specifically, some parts of the Greater Accra region. So this is a Google Map image right up here on the top right of the entire country and where McCarthy Hill, and therefore the underlying McCarthy Fault, actually exists. So it's way down there. And this is an image of the actual hill. McCarthy Hill is a very popular residential area just on the suburbs of Accra, the capital city. It's around 15 minutes from my house. And some of our movie stars, our athletic stars, our soccer stars live on this hill. So you will find quite a few very, very, very expensive mansions on that hill. Why they chose to live on a hill that's on top of a fault, I don't know. I don't know. Offshore in the Gulf of Guinea are 3 main northeast to southwest trending structures and fracture zone faults recognized that reach on shore from the mid-Atlantic ridge and the Romanche transform and fracture zone. The Romanche fracture zone fault occurs at the eastern end of the Romanche transform fault zone. The Greater Accra region is related to the eastern end of the Romanche transform fault, but it's offset roughly 888 kilometers long from the diverging mid-Atlantic ridge. Extending eastward is the Romanche transform fault, which is the 1,890 kilometer long Romanche fracture zone. So that's what this is. And that appears to be the source of most of the seismicity detected around the southern border of Ghana. As I mentioned earlier, McCarthy Fault is located underneath the McCarthy Hill, just outside the Greater Accra region. So it's somewhere around here. So I suppose you could call it the Aquapim Fault, but we call it the McCarthy Fault. McCarthy Hills is named because it used to host the residence of the British governor, Charles McCarthy. He was killed in a battle between the Ashantis and the British on January 21st, 1824, at what came to be known as the Battle of Nsamankau, near present-day Bon Sasso in the Ashanti region of Ghana. Honestly, yay Ashantis, in my opinion, in my humble opinion. And then this is a Google Map image of the actual, this right here, that's the Mid-Atlantic Rift, right there. And lining along it are the fault zones as mentioned earlier. And as you can see, the Romanche Fault Zone goes all the way up into Ghana, and over here, seismic events. Every red dot you see is around a 4 to 5 or 5 to 6.4 fault seismic events. As you can see, most of them are centered around the Greater Accra region, with quite a few of those overlying the actual McCarthy Fault. And here are some references and credits. So this first one up here, that's the article on the most recent earth tremor that hit us just this March. No major damage, no casualties, thank goodness, just a few cracks in the road. And then further down are several textbooks and research papers reprising most of our mineral resources, again, gold. And furthermore, are more seismic activities in relation to fault systems. So if you want to know more about the Romanche Fault Zone and fault systems that overlie Ghana, these would probably be some of your best sources. Again, Professor Johnson Manu, he's a geology professor in the University of Ghana, and he actually helped me find most of these sources. So I credit him with a lot of the research that was done. And that's all. Thank you.